Hi, my name is Fakhry, and for my project I designed a light tank called the Ripsaw, which is used by the US Army. To start, I used orthographic projections of the civilian version, then later referenced other pictures and videos to modify it to look like the mil-spec version. I first made the body. For that, I created a 3D sketch, then used structural members from weldments to create the chassis. I found that using those was much easier than a sweep or a boss base because I could use the trim tool to make the intersections look neater. From that, I built outwards, using many reference planes, extrudes, sweeps, and lofts to create the rest of the body and the minor details. For other parts, I used equations, revolves, mirrors, circular patterns, extrude cuts, fillet and chamfer, shell, and dome. For the simulation, I chose to do the rolled wheel connectors. The total weight of the vehicle is around 11,000 pounds, so I put a load of 2,000 pounds on this part since there are 6 of them. The yield strength of alloy steel is around 90,000 psi, and the max von Mises stress this part experienced is nearly 2 orders of magnitude less than that, which means at full load this part won't fail. Its maximum displacement was also really small, on the scale of a few millimeters, which is fine for a large part which is a few inches thick. I wanted to make the mechanics as realistic as possible, so I made it so everything that could move in the real version could also be moved in the assembly. For the springs, I wanted to make them dynamic, so I used multiple smaller spring sections and mated them together into a full spring, which was able to expand and contract. One big challenge was figuring out how to create the track. I eventually found out that I could create a belt part, then use the chain pattern to wrap the tracks around it. The whole assembly has 778 components, which come from 36 unique parts. This was a challenging build, but I learned a lot about SolidWorks in the process and enjoyed the result. Thanks for watching.